My name is Jing Zhang. This video is for class EL6303 homework 10 question 2 to combine. Number 1 is Y science stationary process. First definition. A real stochastic process xt is stationary in the Y science or weakly stationary if its expected value is a constant and its autocorrelation depends on T1 minus T2 only. That means E of xt equal to constant, RT1 T2 equal to RT1 minus T2. And from the definition we can get the Poisson increment process, Poisson impulse process, and random telegraph signal are WSS processes. But the Poisson process, semi-random telegraph signal, random walk, and Wiener process are not WSS processes. And this process also has some properties. When xt is SSS and E of x square of t exists, then xt is WSS. When xt is WSS, then xt is SSS is not generally true because WSS involves only first and second order moments, and xt and yt are jointly WSS if one is WSS and E of xt plus tau yt equal to rxy tau. Number 2 is independent increment process. Definition. We say that xt is a process with independent increment process if the probability of xta minus xtb smaller than x1, xtc minus xtd smaller than x2 equal to the probability of xta minus xtb smaller than x1 times the probability of xtc minus xtd smaller than x2 for any non-overlapping intervals. And from the definition we can see independent increment implies uncorrelated increment. Then the Poisson process, random walk, and the Wiener process are independent increment processes. Markov process. Definition. Xt is a Markov process if the past has no influence on the statistics of the future and the condition that the present is known. For any n and t1 greater than t2 greater than tn have this equation. And this process also has some properties. First, a Markov process is statistically determined if one knows its second order distribution function f xt1, x1, x2, t1, t2. And also if x1, x2 to xn is a Markov process, then it is statistically determined by second order probability methods. The probability of xi to xi, xj to xj for any ij equal to 1, 2, and so on. And from the probabilities and definition we can find the Poisson process, semi-random telegraph signal, random walk, and Wiener process are Markov processes. Number 4 is normal process. First is definition. A process xt is said to be normal if the random variables xt1 to xtn are jointly normal for any n and t1 to tn. And we can see fx and c are these formulas. And then we can find from this process the statistics of a normal process is determined in terms of its mean and autocorrelation RT1 T2 and CT1 T2. Number 5 is strict science stationary process. First is definition. And this means if it is a SSS process, that two processes xt and xt plus epsilon have the same statistics for any epsilon, and SSS processes also has properties. Xt is SSS if and only if we have these equations true, and xt is SSS. We can see xt equal to fxx. Xt is SSS, then E of xt equal to constant if this constant exists. The number 4, xt is SSS, then we can find fx of x1, x2, t1, t2 equal to fx of x1, x2, t1 minus t2. Number 5, xt is SSS, then we can find rt1, t2 equal to rt1 minus t2. If E of x squared of t exists, we can write t1 minus t2 equal to tau. Then we can find r tau equal to r minus tau. Number 6, xt is normal and WSS. Then we can see xt is SSS. Number 7, random telegraph signal is a SSS process. 6, white noise. The definition is Vt is the zero mean white noise if RVV T1 T2 equal this formula and E of Vt equal to 0. Then from the definition we can find the white noise is a process such that the value at different time xti and xtj are nearly independent. Actually, they are uncorrelated. Also, if xt is WSS white noise, then qt equal to q and E of yt absolute value of yt squared equal to this formula. And number 7 is mean ergodic process. The definition is xt is said to be mean ergodic if limit t to infinite 1 over 2t times the integral xc dt t from minus capital T to capital T equal to E of xt. E means square size. And we can find some properties of this process. E of xt must be a constant, and mean square size means that limit t to infinite E of 1 over 2t times integral xt dt minus the mean value square equal to 0. And xt is a mean ergodic if and only if this equation is true. So this is the second question. Thank you.